All right, so today we're going to start chapter 2. Okay, we're going to spend the whole week just on section 2.2, just that one section. Okay, so we'll do part 1 today, and then part 2 tomorrow, part 3 on Wednesday, and most likely we'll do our test Thursday this week because of the half-day Friday. Okay, so we'll start off with that diagram. So what we have here, basically, this is called a unit circle. Okay, so I've drawn a unit circle. What makes it a unit circle is the length of the radius. Okay, it's 1 unit long. Everything that we do today and tomorrow is all going to be based on a circle that's 1 unit long. Okay, around the axes, I've labeled different degrees. Okay, 0 on the positive x, 90 at the top, 180 on the left, and 270 at the bottom. The basic idea behind unit circle trig is that every angle, okay, on the perimeter of that circle can be represented as a coordinate. Okay, and that's the goal. Every angle can be represented as a coordinate. This coordinate is going to be the key to everything that we do with unit circle trig. If we can't figure out the coordinate that corresponds to an angle, we can't do unit circle trig. Okay, so we've got to be able to find the coordinate. Okay, and when I draw an angle, okay, what I mean is that, let's say we put the angle right there. Okay, there's coordinates for that point. Okay, we can't tell exactly what they are, but there is a coordinate for it. Some that are easy to do is to find the coordinate of something that's straight up, okay, or a 90-degree angle. Okay, 180, that's a pretty easy coordinate because it's just left. And 270. Okay, that coordinate's not bad because it's just straight down. Okay, so let's go back and take a look. See if we can figure out those 4. Okay, pretending that the origin is right here. And that's 0, 0. And remember, the radius of this circle is 1 unit. And I think they have an idea what the coordinate would be that represents 0 degrees. Coordinate for 0 degrees. Adam?
Would be 1, 0.
Yeah, it'd be 1, 0. Okay, all you do is go right 1, and you don't go up and down. That's the coordinate for 0 degrees. And it's always the coordinate. That never changes. Okay, Josh, how about 90 degrees?
0, 1.
Yeah, that's 0, 1. Don't go left and right, you just go up 1. Okay, and again, this is on a unit circle. That's what we're using. Let's try 180. Okay, how about Sam? Yep, it's negative 1, 0. And the last one we'll do 270. How about Amy? Try one more time. Yep, 0, negative 1. Okay, so these are the coordinates that represent those 4 angles. Any questions on how we figured those out? Okay, those aren't bad because all you have to do is measure in a straight line. When we start talking about other angles, we'll have to do a little more work to figure out the coordinate. In general, unit circle trig, we can't use it to represent every single angle. That would be very difficult. Like if you ask me what's the coordinate for 13 degrees, I couldn't do that as an exact answer. There are certain ones we can do. Okay, generally, if the angle is a multiple of a 30, so 30, 60, 90, 120, 150, okay, and so on, or if it's a multiple of 45, 45, 90, 135, 180, 225, and there's some overlap as well. Okay, but if an angle is a multiple of 30 or 45, we can use this circle to do what we're doing right now. If it's not, that's when we're going to use a calculator. Okay, we talked about this last week a little bit, but there's two directions you can move on the unit circle. You can either move in a clockwise or counterclockwise direction. And the only thing that changes is whether you're measuring a positive or a negative angle. So if we move counterclockwise, that's when our angle is positive. If we move clockwise, that's a negative angle. And I'll show that in a second on the other screen. Anybody used to using a compass? Like to navigate? Yeah. If you've used a compass before, this is a little weird because this isn't how a compass works. Does anybody know where 0 degrees is on a compass? That's north. Okay? We've marked it here with the equivalent of east. Well, in mathematics, that's the system that we use with unit circle trig. All right, so if you're used to a compass, it's a little different. Okay, so let me show you those angles. So moving counterclockwise, okay, there's your positive angle. And going clockwise, now we have a negative angle. Okay, the only difference here is one's degrees and then one's radians. Okay, question about the direction of measuring an angle. So what we're going to try to do is always work with an angle that's between 0 and 360. If angles get too big, okay, like if I gave you a problem that the angle was 1,540 degrees, that's kind of tough to visualize. So there's a way we can take an angle that's bigger than 360 and make it smaller. Let me show you an example. Let's say we had, let's do it as a positive. 450 degrees. Okay, based on where I landed, okay, and using the diagram that you have in your notes, what's a simpler way to say 450 degrees? It's the same as what other?
90.
90, that's 90. Okay, so 450 and 90 are the same thing. Does anybody see what you can do to the number 450 to change it to 90? Something you can subtract. Yeah, you subtract 360. Okay, imagine all you've done at 450 is you've gone around one extra time. Okay, so undo that. Go back around the other way one time. Well, if you go back around a circle one time, that's 360. And we subtracted 360 off it. Okay, so to reduce an angle that's greater than or even equal to 360, because we could, if we had a 360 degree angle, that's the same as 0. Okay. So you just keep subtracting 360 until your angle is greater than or equal to 0, but less than 360. Because all we care about is where we end up on the unit circle. We don't care how many times we went around to get to where we ended up. It's just where did we end up. Okay, now this is kind of the opposite problem. Let's say we had an angle that was negative. Anybody else have a thought what we could add to a negative angle to make it positive? Oh, Ethan?
360.
Yeah, it's the same thing. You're gonna add 360 the other way. Let's say here's a negative angle. Negative 450. If I wanted to make it positive, I can add 360 one time. Okay, did that make it a positive angle? Just adding it one time? No. So do it again. Just keep adding 360 till you finally get a positive angle. Would I want to add 360 one more time? No. What would happen if I did that?
It would be only 360.
And now it's going to get too big. Okay, so you can add or subtract 360 as many times as you need to make the angle easier to work with. And I'm only listing the directions here in degrees because most people are more comfortable with degrees. Generally, the first thing people do with this kind of problem, if I give it to you in radians, they change it to degrees so they can visualize it better. Okay, any questions on making an angle smaller or bigger, but equivalent to what we had before? Okay, another name for the kind of angles that you end up drawing when you add or subtract 360, it's called coterminal angles. Coterminal angles are basically angles that have the same initial and terminal side. And that's exactly what we're doing right here. Okay, so 6 trigonometric functions. Okay, for almost every week through the rest of the year, we're going to use these functions. Okay, I showed them to you earlier on the calculator. I showed you 3 of them. And the way that I'm going to define these definitions right now, okay, it's based on a unit circle. And it's based on the coordinates of a point that represents an angle on the unit circle. This isn't the only way to define them. Okay, if SOHCAHTOA, or you're thinking that in your head, that's also the 6 trig functions, except that's in terms of a triangle. Okay, we're going to study the same thing again next week, and then we're going to do it that way in terms of a triangle. Okay, but this week we're using a unit circle. And the first 3 trig functions we're going to look at are sine, cosine, and tangent. Okay, and they're abbreviated SIN, that's sine. COS, it's cosine. And TAN, that's tangent. And the definitions I'm about to write down are going to have all either x's or y's or both of them, because it's all based on the coordinate that represents that angle. Okay, theta, that's the angle. So, if you want to know the sine of an angle, all you need is the y value of the coordinate that represents the angle. If you want to know the cosine of an angle, you need the x value, and only the x value, of the coordinate that represents the angle you want to know. Right now, we only know how to find 4 coordinates. The one for 0, 90, 180, and 270. So if I want you to do something other than one of those angles, I'm going to have to give you the coordinate, because you don't know how to find it yet. Okay, and the last one is tangent. And for tangent, you need both. If you want the tangent of an angle, find its coordinate, and then divide the y by the x value. Okay, so that's the first 3. How many people have heard of those before? Sine, cosine, tangent. Yeah, those are pretty common. Does anybody know the other 3? Yeah?
Cosecant, secant, and cotangent.
Yes. Okay, so the first one is cosecant. And I'm writing them in this, I'm writing cosecant across from sine for a reason. If you want to know the cosecant of an angle,
How do you spell that?
that's C-O-S-E-C-A-N-T. Cosecant. And it's abbreviated CSC. We can't abbreviate it COS because we already used that somewhere else. So we use CSC. This is the only abbreviation that doesn't use the first 3 letters of the long word. Okay, what does it look like the relationship is between sine and cosecant? Think of that as a fraction, y over 1. What would you do with the fraction to get cosecant? Iris? It's what, reversed? Can we be more specific? What's that word when we
Reciprocal.
flip it? Yeah, reciprocal, or you flip it. Yeah. So to get the cosecant from the sine, all you have to do is flip it. That's important to know because there is no cosecant button on this calculator. So if I asked you, what's the cosecant of, 15 degrees? Well, you'd have to find the sine first and flip it. Okay? That's the only way to do it. There's no button for it. And there's not going to be a button for the other two either. It's going to be the same kind of pattern. Okay, we don't know the name of it yet. Well, I'll show you that. It's the secant, abbreviated SEC. And if it follows the same pattern as the one above it, what do you think the secant is going to equal? It's 1 over x. Yep. So the secant is the reciprocal of the cosine. And you could also say the cosine is the reciprocal of the secant. You flip one to get the other. And the last one is the cotangent, abbreviated COT. And what do you think the definition of cotangent is? Yeah, it's x over y. Okay, so the way I've paired these up across from each other horizontally, these are called reciprocal functions. You flip one to get the other. Okay, you also might notice another word that comes up a lot here, co. So we have, I'll just put a mark here, secant, and then we have cosecant. Okay? These two have something in common. They're almost the same thing, except one has the word co in front of it. Okay, we have another pair. Sine, cosine. Okay? These two are also, they have a relationship to each other. And then we have another one that they're already across from each other. Tangent and cotangent. Okay, what I just checked off in the colors, those are called cofunctions. It's basically you take one function, then put the word co in front of it. That's its cofunction. We'll study more about cofunctions later on. But for now, I just want you to understand the reciprocal idea. Okay, any questions on that? Okay. So the angles 0, 90, 180, and 270, they have special names because they're not in an axis. They're on an axis. They're not in a quadrant. Okay, if you were to draw any other angle besides 0, 90, 180, or 270, it would end up in a quadrant. But because these end up on an axis, and an axis is what divides our grid into 4 quadrants, these are called quadrantal angles. So right now, the only coordinates you guys know how to find, the only angles you know how to find the coordinate for are the quadrantal angles.
Is that a cube or is it?
Quadrantal, cube. Bless you. Any question on that? Quadrantal angles or the 6 definitions? Okay. So how do we use the definition to actually find a trig function? Okay, well, first thing you're going to do, if you're going to use one of those 6 definitions, you have to be able to find the coordinate. If you can't find the x and the y value, you can't do any 6 of these formulas. Okay, so you have to be able to locate the point on the unit circle, locate the coordinate that represents the angle you're trying to work with. Sometimes I will give you the point. Okay, for today I want you to try angles other than these four. But since I haven't taught you how to find the coordinate yet, I'm going to have to do step one for you. I will give you the coordinate. Tomorrow I'll teach you how to find it. Okay, so step one, find your coordinate. Step two, use the coordinate you have from step one and the definitions from the previous page, the 6 formulas, to find whatever trig function I'm asking about. On a test, I'm only going to ask you about one trig function at a time per problem. Okay, when we do practice ones in class, I'm probably going to say find all 6 trig functions in the same problem. Okay, but you only have to find the trig function that they're asking about. Does everybody have what's on the left? Let's try a couple examples. Okay, so this is one where I'm giving you the coordinate. It says, let this point be point P. Okay, that's a point on the unit circle that represents an angle. I want to find all 6 trig functions of that coordinate. Okay, do you think that coordinate P represents a 0, 90, 180, or 270 degree angle? Does that coordinate look anything like the ones we did at the beginning of class? You think, Max? No. What number did the 0, 90, 180, 270, what did those have?
1 and 0.
It had 1s and 0s in it. Sometimes the 1 was negative, sometimes it was positive. But it was always 1s and 0s. This has a 1/2 and a square root 3 over 2. This doesn't represent any of those quadrantal angles. And in fact, in this problem, you will never know what the angle is that it represents. But we don't need to. We don't want to know what the angle is. We want to know certain things about the angle. We want to know what its sine is, what its cosine is. Okay, so one way to kind of think about this is all of these 6 things describe the angle in different ways. But you're never going to know the name of the angle. So think about if you met somebody on the street. Okay? You could describe them in all kinds of ways just by looking at them. But you don't need to know their name to describe things about them. You could describe their hair color, their eye color, what shirt they're wearing, color of their pants, and never know their name. That's basically what we're kind of doing here. We're going to describe a bunch of stuff about the angle, but we're never going to know the size of it or its name. Let's start with sine. Right, so Emily, what's our definition for sine? Do you have it in your notes? Okay, so, yeah, why? Okay, so if you don't have these, make sure you've got those 6 definitions. Okay. What's my y value here, Emily? Yeah, and that's it. Okay, so to get the sine of that angle, we just need the y value of the coordinate, square root 3 over 2. Okay, how about Yadira, what's the definition for cosine? X. Okay, cosine equals x. Okay, what's my x value in that problem? looking at your coordinate, where is the x always?
On the left side.
It's on the left side of the coordinates, the first thing. So what's my x here?
Negative 1 over 2.
-1 over 2. Yep. Okay, so there's my cosine. These are the easiest ones because we don't have to do any arithmetic. Okay, that's sine is just y, cosine just x. Now the other ones we're either going to be flipping something or doing some division. Okay, so let's go with our tangent. Ben, what's the definition of tangent?
1 over x.
Nope, not tangent. 1 over x is going to be my secant.
Y over x.
Y over x.
Oh.
Yeah,
Yeah.
y over x.
I just looked wrong.
Yeah. That's right. So it's square root 3 over 2. Divide by -1/2. In fact, let me move that. Okay, how can I simplify that a little bit? Fraction divided by another fraction. Yeah. Yeah, multiply by the reciprocal. Okay, when you flip it, the 2's are going to cancel out. So you get root 3 over 2 times -2 over 1. And all you're left with is negative square root 3. Okay, any questions on how we got the sine, cosine, or tangent? Okay, Ashley, what did I say the relationship was between sine and cosecant? It's just a reciprocal. So if you've got one, all you have to do is flip it to get the other one. It's just the reciprocal. Okay, so Ashley, what do I get when I flip root 3 over 2?
Over the square root of 3.
Yep. 2 over the square root of 3. Okay, now we talked about when we have an answer like this last week. Okay, Sean, what's wrong with this answer? Numerically, it's correct, but what do we have to do?
Put it under 1, possibly? I'm not sure.
Well, it's already got a denominator, but I don't like the denominator that's there. That's part of the problem. Iris, can you help out? Yeah, we can't leave the square root in the denominator. Okay, so what did we multiply top and bottom by to fix that? Yeah.
You multiply it by the denominator.
Yep, which is
Square root of 3
square root of 3 over.
over square root of 3.
Right. So if we end up with a square root in the bottom, which a lot of times we will if we flip something where it was in the top, we have to fix it. So we get 2 square roots of 3 divided by 3. That's my cosecant. Right, Adam, how about my secant?
It's going to be -2.
Yeah, just -2. There was no square root here, so we don't have to worry about flipping that and getting a square root in the bottom. Okay, and Naisha, the last one, we don't have a fraction here to flip. So what can I do to negative square root 3 to make it a fraction? Or same way you could make any number that's not a fraction into a fraction. Like how would you take the number 4 and write it as a fraction? Put a what? Yeah, you put a 1 under it. You just put a 1 under it. So now what do you get when you flip that? It doesn't matter. You can put the negative in the top or the bottom. You just have to put it somewhere. Okay, but 1 over square root of 3. Okay, is it okay, Andy, to leave that as a final answer?
No.
No?
You have to multiply the top and bottom by the square root of 3.
It's exactly the same thing we did for the cosecant. Multiply top and bottom by square root 3. Okay, so this is why I went over that last week. So negative root 3 over 3. On a test, this would have been 6 separate problems. Yeah, but we just did all 6 to practice in the same problem. Any questions on how we found the 6 trig functions of the point up above? And that's it. That's what you pretty much do every time. Okay? Except I normally won't ask for all 6 at the same time. Okay, here's another coordinate. Again, this isn't an angle that's a quadrantal angle because it has square roots in it again. So it's square root 2 over 2 comma square root 2 over 2. Does anybody have a guess at what angle that might be? You draw your unit circle, and you go over square root 2 over 2, up square root 2 over 2. You went over and up the same amount. It is. That's the coordinate for a 45-degree angle. You don't need to know that for this problem. We'll learn that tomorrow. All you need to know are the 6 definitions and apply them to that coordinate. Okay, so why don't you try that one on your own? Take a second, use the exact same definitions we did as the first example. Except now your x and your y value are the same, so some of the calculations are actually going to come out quite a bit easier. Okay, give that a try. All right, so first thing we got to find is the sine. Okay, Michaela, what letter do we use for sine?
Y.
Y. What's y in this case?
Square root of 2 over 2.
Yeah, square root 2 over 2. So that's y. Andrew, what's the definition for cosine?
dx.
X, very good. What's x in this one?
Same thing.
It's the same thing. Root 2 over 2. Okay, and our tangent. Okay, Brandon, what's the definition of tangent?
Y over x.
Y over x. So what are we going to get this time if we take y and divide it by x?
1.
1. How come?
Because you're dividing by itself.
Right, we're dividing two things that are the same. So if you do y divided by x, you're going to get 1. Okay, now that we have the sine, what do we do with the value for sine to get the cosecant? Yeah, go ahead. Flip it. Okay, so we flip it. You get 2 over root 2. And Olivia, what do I do to fix having the root 2 in the denominator?
You multiply it by square root of 2 over square root of 2.
Okay, so multiply by square root of 2 over square root of 2. We're going to get 2 root 2 divided by 2. But what happens there now? The 2's cross out. We get just the square root of 2. Now that we have the cosecant, the secant should be really quick to find. Josh, what's the secant here?
I didn't get the secant or the cotangent on those ones.
What do you do to get the secant? Do you remember?
I understood like everything else that was the one and then the drawing, so.
Anyone help him out? If you have the one on the left, what do you do with it to get the one on the right? You just flip it.
But it's going to be the same because it's
But we've already done that. We've already flipped the one above it. Okay? So since sine and cosine are the same, cosecant and secant, we're flipping the same thing. They're going to be the same. Okay, and the last one is the cotangent. How about Zach? What's the cotangent?
1.
1. Okay, when you flip 1, you get 1. It's one of the two numbers that you can flip, and it stays the same. The other one being negative 1. If you flip that, it stays the same. Okay, any question on the 6 trig functions here? All right, so this is going to be the last one I do, where I do it as a coordinate. I want to try one with an angle next. So try those three, and then we're going to move on to something else after this. Let's take a look, see what we got. So we'll start with the sign. Okay. Shelby, what's the sign? Yeah, negative 1/3. Okay. Just my y value. Okay, my cosine. Tom? Yeah, just 2 square root 2 over 3, just the x. And my tangent. Paige? How do I find it?
It's negative 1/3 over 2 square root of 2 over 3.
All right, so it's negative 1/3, that's my y, divided by 2 root 2 over 3, that's my x. What happens when you have the same number as the denominator in a fraction in the top and the bottom? Yeah, they cancel out. Okay, if you don't like it that way, you can just flip and multiply. That's the same thing. Okay, so now we're left with negative 1 over 2 root 2.
And times the 2 root, and times the 2 root of the 2.
So we only have to multiply top and bottom by what we don't want in the bottom. Just the root 2. Yep. Okay, keep this answer though. Don't erase it or cross it out because that's going to come in handy in a little bit. Okay, so we fix this one. We get negative root 2 in the top. And in the bottom, we're going to get 2 times the square root of 2 times the square root of 2. That's going to be 2 times 2, or 4. Okay, so that's my tangent. Now we just have to flip each one to get the other 3. There's my cosecant. Secant is 3 divided by 2 root 2. Very similar problem we just had when we did tangent. So we'll fix that. And the 3 root 2 in the top, and we're going to get 4 in the bottom. Okay, now the cotangent. We have 2 different things we could flip. Okay, this was the original one we had, but we didn't leave it like that because of the square root in the bottom. And then this was the final answer. Which one of the squared box or the one I have circled, which one would be easier to flip to find the cotangent? Yeah.
The first one,
Why the first one? Yeah.
because you would do the same thing if, like, the 1/3 divided by, you would have to, like, get rid of 3 anyways.
Okay, so in either one here, the 3's already gone. But one of these is much better to flip. It's going to be faster. And they are equivalent. But Iris, yeah, which one?
If you flip the negative 2, the negative square root of 2, there'll be another square root at the bottom, so you have to do it over.
Yeah.
Whereas if you just flip the 2 over square root of 2, everything else out.
Right. If you flip the final answer we have here, you're going to get a square root back in the bottom again, and then you're going to go through all that work. If you flip the one that I put a box around, the square root goes to the top and you're done. So the final answer is negative 2 root 2. It would be divided by 1. Okay. But flip either one, you'll get the same answer, it's just more or less work. All right, so the next one I want to look at, this time they're going to give me an angle. Okay, if they give me an angle, I haven't had to do it yet, but what's the first thing I said you need to do if you're given an angle? Right, you're going to put the coordinate. So now we need to figure out the coordinate for 90 degrees. Okay, but we did that earlier. Does anybody remember what the coordinate was for 90? Yeah, go ahead.
0, 1.
0, 1. Now we can do this problem just like the other ones. Because of the 0 and the 1, the arithmetic should be really fast. There's no roots, so it shouldn't take long at all. Zach, what's the sine of 90?
1.
1. Yep. That's it. Max, what's the cosine?
1. No, 0.
0. And the tangent? we have y divided by x. What happens when you do 1 divided by 0? Okay, we have a guess for 1, we have a guess for 0. Anything else? Undefined, that's a third guess. A number divided by 0 spells no. Okay, so in Algebra 1, I teach them you cannot divide by 0. So the answer is you can't do it, but what do we write? We do write undefined. Tangent of 90 is undefined. Can't do that. Okay, how about Josh, what's my cosecant?
1.
1. You flip 1, you get 1. Stays the same. How about the secant? What's the secant of 90? Oh, it can't be 0, because 0, when you flip 0, you don't get 0. This is 0 over 1 on the left. Right, when you flip it, it's undefined. So when you flip 0, you get undefined. How about when you flip undefined? You get 0. Remember, tangent of 90, that was 1 divided by 0. So when we flip it, we have 0 divided by 1. That is 0. Okay, any questions on that one? Okay, this one I want to do all 6. Okay, we've been practicing all 6. Let's just do the first 3. I want the sine, the cosine, and the tangent of 3 pi. What would be a good first step here to make this in units that are a little more familiar to us? Yeah, change it to degrees. Okay, if you know how to work with 3 pi, just do the problem the way it is. Don't even bother changing it. But if you're not, we can convert it to degrees. Okay, Sam, how do I change 3 pi to degrees?
180 over pi.
Multiply by 180, divide by pi. 3 times 180 gives me 540 in degrees. Now 540 is okay, but that's kind of a big angle. Sean, you remember what we can do with that to make it smaller?
Yeah, you go clockwise to make it, so it would be minus 360.
Yep. So really, we're only working with a 180-degree angle. Now we know our angle. We've made it small enough we can work with it. Does anyone remember the coordinate for 180? Iris? Yep, negative 1, 0. Now our sine is the y value. Cosine is the x. And tangent is y divided by x. If you wanted the other 3, you just flip them. Okay, any questions before we finish up with our last problem? Okay, so for the last one, I want the 6 trig functions of 11 pi over 2. And again, keep in mind, you only know how to find the coordinates for certain angles. So that should already narrow down what this answer is going to be. It's going to be one of 4 numbers. 0, 90, 180, or 270. Okay, so give that one a try. So when you convert 11 pi over 2 from radians, anybody get the final answer in degrees? 270, yeah. Okay, the way you do it, multiply by 180 over pi. When you do out that, did you get 990?
Yeah.
Is that what it started as? Okay, that's really big, so you're going to have to subtract 360 more than once here, a couple times. and it brings you to 270. Okay, so there's your angle, 270. What's the coordinate for 270? That's straight down. Yep,
0, -1.
0, -1. Now we just fill it in. Okay, so my sine, Naisha, what's my sine? Yep, -1. Okay, Andrew, my cosine? 0. And Andy, my tangent. It's undefined. We're dividing by 0. And now we flip them all up to get the other ones. Flip -1, it stays the same. What do you get when you flip 0? That's undefined. Think of it as 0 over 1, and you flip it. It becomes 1 over 0. What about when you flip undefined?
0.
You get 0. Okay. So that's it for this part of the unit circle trig. Okay, so for tonight on 116, I'm just going to have you look at 11 to 27 odd and 22. Okay, and that's